Good morning. In this session, I am going to start the new topic for you, which is very important for your JEE and NEET, electrostatics. Actually, in your syllabus, it is mentioned as charges and fields. So, in this electrostatics, from the name itself, we can say static means stationary. So, we will be studying something about stationary charges and their electrical influences. So, first let us try to understand what is the charge and how we can electrify a body or we can charge a body, we are going to learn. And coming to the case of charge of a body. Charge of a body. So, usually atoms are electrically neutral. They have equal amount of positive charge concentrated in the nucleus, surrounded by equal amount of negative charge surrounded by orbiting electrons. So, actually body gains, if a body gains electrons, it acquires negative charge. On losing electrons, body acquires positive charge. So, charge is due to the transfer or gaining or losing of electrons. Protons cannot be transferred from one object to the other object, but electrons can be transferred from one object to the other object. So, basically on losing electrons, body acquires positive charge, and on gaining electrons, body acquires negative charge, because electrons are negatively charged particles. So, the first point I talked about is on losing electrons. Electron is represented by E minus. On losing electrons, body acquires positive charge, and on gaining electrons, body acquires negative charge, and the charge of the electron is 1.6 into 10 to the power of minus 19 coulombs. We take it as negative because charge of electron is always negative. Another interesting thing is charge is quantized. Charge is quantized, meaning charge of a body can be an integral multiple of charge of electron. So, suppose if Q is the charge of a body, Q is equal to Ne, where N is a positive integer. It cannot be a fraction. A body can lose or gain integral multiple number of electrons, but can never be fractional multiple number of electrons. That means body can gain 1 electron, 2 electrons, 1000 electrons, 10,000 electrons, but a body cannot gain or lose 1.2 electrons, 1.3 electrons, like that. So, gaining or losing of electrons is an integral multiple of number of electrons. The gaining or losing the number of electrons gained or lost will be an integer, but it can never be a fraction. So, charge of a body Q is equal to Ne, where N is the number of electrons lost or gained, E is the charge of the electron. In this, just I am giving you an example. Suppose if a body has 1 coulomb of positive charge, how many number of electrons the body has lost or gained? That is the question. Here it is given that body has a positive charge of 1 coulomb. How many number of electrons it has lost or gained? That is the question. See here, positive charge means that itself implies body has lost electrons. So, positive charge implies body has lost electrons, and as Q is equal to Ne, Q is 1 coulomb, N we do not know, charge of electron is 1.6 into 10 power minus 19 coulombs. So, from this N is equal to 1 by 1.6 into 10 power minus 19, that if you simplify that, that will be 6.25 into 10 to the power of 18. See here, charge of an electron, we never forget, that is minus 1.6 into 10 power minus 19 coulombs. 1 coulomb of positive charge implies that the object has lost 6.25 into 10 to the power of 18 electrons. So, on gaining or losing electrons, body acquires charge. On gaining, acquires negative charge. On losing, acquires positive charge. Number of electrons lost or gained if the charge of a body is 1 coulomb is 6.25 into 10 power 18 coulombs, and charge is quantized because Q is equal to Ne, N is always a positive integer. Now, law of electrostatics is like charges repel each other, unlike charges always attract each other. Okay, that is the law of electrostatic forces. This is something about charge. And next, let us see methods of electrification. Methods of electrification. Look here. So, we are going to see the methods of electrification. Right? Now, look here. The first method of methods of electrification. So, the first method of electrification is friction. Friction. Two neutral bodies are placed in contact with each other and rubbed with each other. So, here two neutral uncharged bodies are rubbed with each other. Then the body with less electron affinity, loses electrons and becomes positive. The other with more electron affinity gains these electrons and becomes negative. That is the principle of electrification by the method of friction. So, the two uncharged bodies are rubbed with each other, then the substance with less electron affinity loses electrons and becomes positive. The substance with more electron affinity gains electrons and becomes negative. This implies that the bodies acquire equal and opposite charge. Equal and opposite charge. That is, one acquires plus Q and the other acquires minus Q, because the number of electrons lost by the first object are being gained by the second object. So, the two objects acquire equal and opposite charges. So, very obviously friction precedes attraction, because the two objects, they acquire equal and opposite charges, and unlike charges always attract each other. So, friction precedes attraction. That is the first method of electrification, friction. And the second method of electrification is conduction. Conduction. Here an uncharged body is placed in contact with a charged body. Let this be a sphere which is uncharged, and this rod is a charged body. Uncharged body is placed in contact with charged body. Then redistribution of charge takes place. Redistribution of charge takes place till their potentials are equal. This is the important word here. So, charge redistributes. So, this also acquires similar charge until their potentials are equal. Their charges are of same nature, but magnitudes need not be equal, but conditionally their potentials must be equal. So, in the method of conduction, uncharged body is placed in contact with the charged body. Then redistribution of charges take place till their potentials are equal. So, here the two charges are similar, hence conduction precedes repulsion. Conduction precedes repulsion. Precedes means conduction is followed by repulsion. And here another condition is only conductors can be charged by this method. Insulators cannot be charged by the method of conduction. Only conductors are being charged by this method of conduction. So, that is the second method of electrification, conduction. And the third method of electrification is known as induction. Here, let this be a charged body. Uncharged body or neutral body is placed nearer to it. It is not placed in contact, it is just placed nearer to it. Then dissimilar charge is induced on the nearer end and a similar charge is induced on the farther end. Now, here next thing what happens is, this is positively charged. So, this is placed nearer to it. So, dissimilar charge is induced on the nearer end and similar charge is induced on the farther end. Suppose if this is earth connected, then the entire positive charge goes to the earth. Only negative charge will be remaining on this object. So, if you want to charge this body negatively, then just if you earth connect the other end, automatically that entire body will be negatively charged. So, let Qi be the induced charge here, Qi, this one. This is Qi with the induced charge, Q naught is the inducing charge. The relation between them is Qi is equal to Q naught into 1 minus 1 by K. This we will be learning in capacitors basically. So, here K is known as the dielectric constant of the material. Dielectric constant of the material. For metals, in case of metals, K is equal to infinity. If K is infinity, what happens to the value of 1 by K? Becomes 0. So, Qi is equal to Q naught in case of metals. So, in the method of induction, uncharged body is placed nearer to the charged body. On the nearer end, dissimilar charge is induced. On the farther end, similar charge is induced. And here, if you earth connect that, dissimilar charge will be retained on the nearer end. And very obviously, this precedes attraction, because in this case, they are dissimilar charges. Even in this case, as dissimilar charges are closer, attraction dominates the repulsion. Attraction between these two dominates the repulsion, hence induction always precedes attraction. And the expression for induced charge is Qi is equal to Q naught into 1 minus 1 by K, right. Now, next we are going to see Coulombs law. Coulombs law. This law gives us the expression for force of attraction or repulsion between electric charges. Let us consider two charges Q1 and Q2 separated by a distance r. Force of attraction or repulsion, if they are dissimilar, attraction will be there. If they are similar, repulsive force will be there. So, force of attraction or repulsion between the two charges is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. So, F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square if the two charges are in air or free space. In air or free space. See here, the proportionality constant is 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught value is 9 into 10 to the power of 9 Newton meter square per Coulomb square. You need not by heart this, isn't it? Simply 1 by 4 pi epsilon naught F into R square Newton meter square by charge square Coulomb square. So, 1 by 4 pi epsilon naught 9 into 10 power 9 Newton meter square per Coulomb square. Now, epsilon naught is called permittivity. Epsilon naught is called permittivity of air or free space. And epsilon naught value is 8.852 into 10 to the power of minus 12 Coulomb square per Newton meter square. Coulomb square per Newton meter square. Actually, epsilon naught from this expression, epsilon naught is equal to 1 by 4 pi 9 into 10 to the power of 9. If you simplify that 8.852 while solving the problems, we approximately take it as 9 into 10 power minus 12 Coulomb square per Newton meter square. And in units and dimensions, we will be doing problems based on the dimensional formula for epsilon naught. Actually, epsilon naught dimensional formula is so simple from this expression. For epsilon naught, Coulomb is because Q is I into T, or I is rate of flow of charge, I is equal to Q by T. So, Q is equal to I into T. So, dimensional formula for Coulomb becomes AT whole square. Newton is force unit, M L T power minus 2 L square. So, for epsilon naught dimensional formula A square T square by M L cube T to the power of minus 2, or this is M to the power of minus 1 L to the power of minus 3 T to the power of 4 A square. That is the M to the power of minus 1 L to the power of minus 3 T power 4 A square. That is the dimensional formula for epsilon naught. So, on this page the most important thing is force of attraction or repulsion between two charges separated by some distance in air or free space is F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. Epsilon naught is the permittivity of air or free space. Its value is 9 into 10 power minus 12 approximately, or accurately 8.852 into 10 power minus 12 Coulomb square per Newton meter square. And dimensional formula is m power minus 1 L to the power of minus 1 T power 4 A square. While doing calculations, we will be taking the value for 1 by 4 pi epsilon naught as 9 into 10 to the power of 9. 1 by 4 pi epsilon naught is equal to 9 into 10 power 9. So, in the previous page, just we learn this point. When two charges are placed in air or free space, force of attraction or repulsion is given by 1 by 4 pi epsilon naught Q1 Q2 by R square, where epsilon naught is the permittivity of air or free space. In any medium of permittivity, epsilon. Can you guess the formula? It's very simple. F is equal to 1 by 4 pi epsilon Q1 Q2 by R square. Epsilon is the permittivity of the given medium in which the two charges are placed. Epsilon and epsilon naught have the same units and same dimensional formulae. Unit for epsilon will be Coulomb square per Newton meter square, and dimensional formula is exactly same as that of epsilon naught. Next we are defining another one, dielectric constant. Dielectric constant, we also call it as relative permittivity. Relative permittivity of the medium. Dielectric constant, relative permittivity, or sometimes we also call specific inductive capacity. It is represented as K. K is equal to epsilon by epsilon naught. Relative permittivity, that is the ratio of permittivity of the medium and permittivity of air or free space. So, K is equal to epsilon by epsilon naught implies epsilon is equal to K epsilon naught. Substituting this in this equation, force of attraction or repulsion between two charges in a medium of dielectric constant K is given by 1 by K times 4 pi epsilon naught Q1 Q2 by R square. This is another expression. So, altogether we talked about 3. In air or free space, F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. In a medium of permittivity epsilon, F is 1 by 4 pi epsilon Q1 Q2 by R square. In a medium of relative permittivity K, F is equal to 1 by K times 4 pi epsilon naught Q1 Q2 by R square. Okay. Now, force is a vector quantity. Suppose if you want to find out the expression for net force on a charge, we have to find out the individual forces created on that charge, and vector sum of all the individual forces gives us the net force acting on the charge. So, I will start with 2 simple examples. Okay, just note down the problem. From below, find the net force acting on the charge Q placed at the point P. Placed at the point P. See here, in this, the first example is, this is a square of side A. This is a square of side A. Charges are placed like this, plus Q, plus Q, plus Q. 4 identical charges plus Q each are placed at the 4 corners. Let A be the side of the square. Let P be the point at which the charge plus Q is placed. We need to find out the net force acting on the point P. So, here follow me very carefully. Let us name the corners. This as 1, this as 2, this as 3, this as 4. This is plus Q, here there is plus Q charge. So, on this exerts repulsion in this direction. This is plus Q, this is plus Q, it exerts repulsive force in this direction. This exerts repulsive force on this in this direction. This also exerts repulsive force on this in this direction. See, 1 means F1, that is the force of repulsion between this Q and this Q. So, we need to find out from Coulombs inverse square law, 1 by 4 pi epsilon naught Q1 Q2 Q square by this distance What is the distance between these 2 points? Distance of each corner from the center of a square is a by root 2. So, q by distance square, a square by 2, that is F1. Now, F2, force between them, it is 1 by 4 pi epsilon naught q square by a by root 2 whole square, the same. So, what we get here is F2, F3, F4, all of them, they are equal to F1. So, this experiences forces in all these 4 directions of same magnitude 1 by 4 pi epsilon naught q square by a square into 2. Now, look at these 2 forces, 1 and 3, they are equal in magnitude, opposite in direction, they just cancel each other. 4 and 2, they are equal in magnitude, opposite in direction, they too cancel each other. So, the net force acting on the charge placed at the center of a square is 0. Similarly, we can prove that the net force acting at the on the charge placed at the center of an equilateral triangle. Suppose if this is an equilateral triangle, identical charges are placed. If we place any charge here, net force on the charge placed at the center is 0. If you take a hexagon, if we place identical corners, identical charges at all 6 corners of a hexagon, if you place any charge at the center, net force on the charge placed at the center of the hexagon is 0. I am just drawing a hexagon. See, identical charges plus q each are placed at the 6 corners of a hexagon. If you place any charge here, net force on the charge is 0. Similarly, if you take a cube, if you place 8 charges at the 8 corners of a cube, if the charges are similar and identical, have the same magnitude and same nature, then whatever is the charge placed at the corner of the cube, net force acting on the charge placed at the center of cube with identical charges placed at its 8 corners is equal to 0. Okay, just if you have that point in your mind, it is very simple to get the answer. Now, look here, find the net force on the charge placed at the center of a square when the charges placed at the corners are given like this. See here, at P a charge plus Q is placed. You need to find out the net force. Find the net force on the charge placed at P. On the charge placed at P. That is the question. So, look here carefully. This is positive charge because a charge, positive charge is placed at the center. So, let us write that positive charge here. So, plus Q is placed at the center. Now, this is charge plus Q placed at the center. Let us name the corners 1, 2, 3, 4. Now, let us try to find the force on this charge due to the charge placed at corner 1. These two charges are similar. So, this exerts a repulsion on this charge. So, F1 will be in this direction. Exactly in the same way, this acts repulsion and it will be in this direction. Coming to the charge placed on the corner 3. This is negative, this is positive. It exerts attraction because they are dissimilar charges. And here, the charge, this charge is negative, this charge is positive. This is also attraction. So, the 4 forces acting on that charge due to these charges placed at the corner are shown like that. Now, all the 4 forces are equal in magnitude. Just in the previous problem also we have proved that, because force is 1 by 4 pi epsilon naught product of the charges q into q by square of the distance a by root 2 whole square. So, this product of charges is q square and this distance is also equal to a by root 2. As all the corners are at equal distances from the center of the square, all the forces are identical. Now, you need to follow this very, very carefully. Look here, F1 and F3 are equal and in the same direction. Their resultant is F13. When two equal forces are in the same direction, resultant is 2F. So, here the resultant of 1 and 3 becomes 2 times 1 by 4 pi epsilon naught q square by a square into 2. Similarly, F24, they are also equal and in the same direction. Their resultant is also 2 into 1 by 4 pi epsilon naught q square by a square into 2. If you look at these two, F24 is in this direction, F13 is in this direction, they are equal in magnitude. Angle between the diagonals of a square is 90 degrees. When two vectors of same magnitude are at right angles to each other, resultant is root 2 times. So, root 2 times this is 1 by 4 pi epsilon naught q square by a square, 2 2s are 4. So, the net force acting on the charge placed at the center in this case is 1 by 4 pi epsilon naught q square by a square 4 root 2. Okay? So, I will stop here for today. When you are coming for tomorrow's class, you have to be absolutely thorough with the concept, then you can do the rest of the problems so easily. If you do not read today, it is going to be very difficult in tomorrow's class. Thank you and bye-bye.